the case of question 3, what we're going to do is to prepare graphs of each of those following sequences up to the 6th term. Now, probably best off using grid paper, but if you don't have any, it's quite easy to draw. First thing we need to do in these questions, for the cases of the arithmetic sequences, we need to be able to expand them and write them in the form of n. When we do that and enter it onto our sequence mode, we can either go straight from the table to a graph, or if you choose, you can generate a graph sequence like so. Now, zooming there, I can zoom in, zoom out, change my zoom box. So I can adjust it like so. I might make that 0 up to 7. The scale is a bit crazy there, so I'll make that 1, 0, and I'll make that going up to 60, and I'll have a scale factor of probably 5, might work better there. And okay, that might make it easy for you to graph it. Of course, I can then go analysis, trace, and just cursor along the graph like so. Now, when it comes to sketching this, just get hold of some graph paper, and with some graph paper you can quickly generate a graph like so. If I didn't have graph paper handy, I might make that X scale 1 centimetre and the Y scale a line going up in 5s. Show them as discrete points and not a continuous line, because we're dealing with discrete data points. In the case of C, we've got an A of 4 and we've got an R greater than 0. So greater than 1, I should say. So we're going to see an exponential growth. So we'd expect a graph looking of the following form. So when I generate that on my calculator, putting that in, I would firstly normally generate my table. And once the table's generated, I could either choose to put that straight into the graph, scaling from 5 through to 30. I want the AN term, and clearly I can adjust that scaling appropriately. So when you come to sketch it, you should have something looking like the. So choose an appropriate scaling. 1 to 6 might be in centimetre intervals. You could use a line interval on your page to show 5, 10, 15, 20, 25, 30, etc. Now, in the case of 3E, we've got a scenario where we're starting at minus 50, or would be minus 45, I suspect, and going up in gradations of 5. I just need to expand that so I can work a little bit better, both on my graph and on my sequence mode. So Tn is equal to 5n minus 55. Now, if I enter that on my calculator, I'll have 5n minus 55. I generate my table values, and you can see minus 50, minus 45, minus 40, 35, and 25, etc. I'll just get some graph paper and show you how we could graph that for n is equal to 1 to 6. So I could set up my graph in a similar way to what I'm doing here, or exactly the same way as I'm doing here. It's up to you. I could have gone intervals of 5 rather than what I'm doing here. So it starts off at 50 and then goes up in intervals of 5. So my 6th term ends up at negative 25. Now when it comes to 3G, I've got Tn is equal to minus 50 times 0.5 to the n minus 1. Now, whilst this isn't a graph form that we usually meet in the course, it is something that's very easy to generate. So I've entered the formula there, starts at -50 and progresses towards the 0. Now, clearly here, I'm going to have to do some adjustments to my scaling, or I could just simply drag it up like so. Now, how you go about graphing that is very, very much up to you. You can see my -50 there at n is equal to 1, and then drifting closer to the axis. Once again, if you do that on your graph, you'll find, graph paper I should say, you'll find that a scaling of -50 through to +10, so you can see above the axis would help, and you can see the function growing towards the 0. And lastly, I'd like to take you through one that doesn't do anything. If I've got the function Tn is equal to 40 times 1 to the n minus 1, Tn is always equal to 40. Now, if you want to just quickly check that on your graph, you can see the flat line appearing pretty quickly. I won't even bother graphing that.